All right. Welcome, Abby and Bailey. Unfortunately, my audio crashed again with the short in my cord, and I didn't get a recording of class. So this is going to be a re-record, but I've got to get it done in on a limited time frame here, so I'm going to use the notes I've already written in order to speed this up. What we're trying to do today is very much related to what you did last class. Last class you learned how to convert numbers or coordinates between polar coordinates and rectangular coordinates. And you also learned how to convert between polar form of a complex number and rectangular form. And I hinted last class that our major reason for doing that was so we could work two kinds of problems, which you'll see up here. The first one, I have 2 square root of 3 minus 4i to the 10th power. We decided that that would be really difficult to do if we had to do it by hand. But if we turn it to polar form, it is actually pretty sweet and easy. The second problem we can solve in polar form easier than what we can solve with algebra is when you're solving for x to raise to some power. We know that in this case, when I do a fourth root, I would get an answer of the fourth root of 5, but there really are 4 answers. So the fourth root would give me plus or minus fourth root of 5. That's 2 answers. There are 2 more which are complex. I can't find other roots of things unless I can use polar form. So, however, before I can teach you how to do polar form, you have to learn how to multiply and divide in polar form. So this first problem is actually asking you, okay, how would I multiply 2 numbers that are already in polar form? Well, the first time here I'm going to take you through it the long way, and then you'll be able to see a shortcut. So logical choice probably here would be to multiply the 2 and the 5 out front so that we get 10, and then we would need to FOIL the 2 binomials. So I actually did that here. Don't worry, you're not going to have to do it that way. I put the 2 and the 5 multiplied out front as 10, and then I FOILed and ended up with 4 more terms. And you'll notice it's pretty busy. I couldn't take cosine of 30 times cosine of 70 and make it cosine squared because those are 2 different angles. So I actually ended up with 4 different separate terms here. But you may be going, hold it, I've seen something that looks like this before. And if you notice, I have underlined in purple here the cosine of 30 and the cosine of 70, the first term. The last term had become an I squared, which we made into -1, and we had sine of 30, sine of 70. And hopefully you're saying to yourself, hey, I think that's one of those A plus B identities. So if you look on your yellow sheet on the back side, you'll see that, yeah, there's an identity, cosine 30, cosine 70, minus sine of 30, sine of 70, is your cosine of A plus B identity. So what we did is we said, okay, I'm going to convert the 2 purple ones. I can just make that the cosine of A plus B. In our case, that's 30 plus 70. Then I'm going to go do the same thing with the 2 terms in the middle, the yellow terms. If I pull the I out front, you'll notice that cosine 30, sine 70, and sine 30, cosine 70 are actually part of the sine of A plus B identity. So I am going to do the sine of A plus B here instead of having to write out all those terms. Consequently, when you simplify this answer, you're really only adding those angles, and they both conveniently turn out to be 100. So I am back to an answer in polar form. I have 10 times the cosine of 100 degrees plus I sine of 100 degrees. Well, now what I wanted you to do, what this arrow down the left side is I'm trying to get you to realize that how could I go from the first step to the fourth step and to do all that stuff in the middle? And yes, it really is as simple as it seems. To get down to step 4 here, I would simply have had to multiply the 2 and the 5 that are in front of the original problem. So I'm looking at the original problem. I multiplied 2 times 5, got 10, and I simply added the angles, which became cosine of 100. That's all that is to it. So it's actually amazingly simple. What I have down here at the bottom is the actual formula for doing this, And that formula you need to put on your journal. And you need the entire formula on the journal, both lines, because the top line is showing you that if you have one number in polar form written with all subscripts of 1, and the second number you're multiplying all with subscripts of 2, when you multiply two variables together, you simply take first the radius times the radius, and you add the angles. Okay, this last problem I have down here was just an example of us actually doing a problem now that we know the shortcut to multiplying. So I had the 25 times the cosine 143 plus I sine 143 times 8 cosine of 207 plus I sine of 207 degrees. All I needed to do to multiply those is multiply the r's out front. So we took 25 times 8 and got 200. And then I simply added the angles. 143 plus 207 makes 350 degrees. And if they want your answer in polar form, you're done. If they want it in rectangular form, you have to convert it back. So it really is that simple. Now that we know we're that brilliant, you can figure out how to divide just as easily. When you divide, it's exactly what you'd expect. If multiplying calls for you to multiply the r's, dividing says divide the r's. And instead of adding the angles, you do indeed the opposite. You subtract them. It's the top angle minus the bottom angle. That's important. So once again, that particular formula needs to go onto your journal, the whole thing, both sides. But in reality, working the problem is way simpler than writing out the formula. In this particular problem, I'm asking you to do the division and then change it back to rectangular form. So this is the problem we started with. 15 cosine of 340 plus I sine 340 divided by 3 times the cosine of 550 plus I times the sine of 550. All you'll need to do is divide the r's, the 15 divided by 3, which is how we got this 5 out front, and subtract the angles. Now, since it's top minus bottom, the larger number is on the bottom, so when we subtract it, we get actually a negative 210 degrees. They're never going to want negative angles in your answer, so if you get negative angles, you will have to get rid of them. And hopefully you remember that on your yellow identity sheet, right below the fundamentals, there are 3 little rules that tell you what to do with negatives. And it tells you that when cosine has a negative angle, we simply drop it and make it a positive angle, because cosine is an even function. On sine, we know we need to pull the negative out front, which in our case is in front of the I. So that's what I did on this next step, is I simply dropped the negative on the cosine of 210, pulled the negative out in front, so it's now minus I sine 210. If they want your answer in polar form, that's where you would be done at. However, this one wanted us to change back to rectangular form. So we actually had to convert it back by figuring out what was the cosine of 210 degrees and the sine of 210 degrees. Well, being the special angle experts that we all are now, I went 210 is in the third quadrant, and it had a 30-degree reference angle. So we needed the cosine of 30, which is square root of 3 over 2. It's in the third quadrant, so it's negative. Sine of 30 degrees is a half, and it's also negative in the third quadrant. An important thing to note, if you're working with polar form, if cosine is square root of 3 over 2, sine will be a half, and vice versa. If cosine is a half, sine will be square root of 3 over 2. All I did then at the end was I distributed the 5 to both parts, and since 5 won't cancel with the 2, we're stuck with the fraction still, and we ended up with negative 5 squared root of 3 over 2 plus 5 halves I. And that, in a nutshell, is division. All right, now, moving on. Here's where the meat happens. A lovely little process made famous by a French mathematician named de Moivre. And, of course, in class, they immediately said, well, it can't be any good, he's French. So obviously Mr. Hermite has warped them well. De Moivre is not one of your big-name mathematicians. This is one of the things he's known for. There's a few other things in more advanced math, but this is one of the biggies. But you all are just as good a mathematicians as Dame of Y is, because you could figure this one out for yourselves. I want to take a number in polar form to a power. In this case, I have the nth power up there. I am going to change that, however, for a moment so you can think in numbers. I'm going to change that to be a third power. And when it's a third power, I want you to realize that if you're taking something to the third power, that means take it times itself 3 times. We just learned how to take something and multiply two numbers in polar form, and that's all I'm asking to do here, is I want to change it to polar form. So if you think about writing out 3 expressions times themselves, what do we do with the r's when we multiply things in polar form? We multiply the r's. So you would have r times r times r, or you would end up with r cubed. We also learned when you multiply numbers in polar form, you add the angles. So in this case, you would have a theta plus another theta, which would in reality give you 3 thetas. So if I was doing this cubed, that would be my solution. However, I wanted this formula for any power, so now I'm going to turn it all back to the n's I originally had there. If you have it to any power, you can simply, and I multiply the angles times that number. So showing you a real quick one here that's nice and easy. If I have this 5 cosine of 70 degrees plus I sine 70 to the 4th power, I simply need to take 5 to the 4th. That's how I got 625. It's 5 to the 4th. And then I multiply the angle times 4. And 4 times 70 is 280. If they want your answer in polar form, you're done. It's that fast to take something to a power. Way easier than if this was in rectangular form and I had to FOIL 4 of those. Taking something to a power when you're in polar form is awesome. The problem is you have to get it in polar form first. So here's the ultimate example of that type of problem. Suppose I asked you to take 2 square root of 2 minus 2i square root of 2 to the 6th power. That would be nothing short of nightmarish to do if you had to do it by hand and FOIL 6 quantities. It's bad enough to FOIL 6 quantities, but then having 2 square root of 2 as the numbers inside, that's really ugly. So, while yes, this takes a little work to convert it to polar form, it's still going to be faster than if you sat there and tried to FOIL it all. What we did then is we drew a graph of our situation. We went over 2 square root of 2 and down 2 square root of 2. And immediately noticed that, hey, wow, those are the same sides, 2 square root of 2 and down 2 square root of 2. So some of them spotted that was going to be a 1, 1 square root of 2 right triangle, or which meant it had to be 45 degrees. But if you don't spot it, I came over here and did this tangent, and did tangent is equal to 2 square root of 2 over negative 2 square root of 2. I did y over x, or opposite over adjacent, whichever way you like it. And that would reduce to 1. Well, we know tangent equals 1 at 45 degrees. So that's why I have 45 degrees as my reference angle. And then I simply need to name that angle it's in the 4th quadrant, so I would have to go around, and that would become 315 then. So now I know what my angle is. To get r, the radius, which actually we already have written on here, but I'll pull this down. If you want to do r, of course, we had to do Pythagorean theorem over here on the far right side. And we did the Pythagorean theorem, 2 square root of 2 squared plus a negative 2 square root of 2 squared equals r squared. When we squared those, we got 8 plus 8, which would be 16, and the square root of that is 4. So it turns out r is a nice plain old 4. Before I get rolling here, I'm about to run out of time, so I'm going to pause this right now and come back and finish this problem and then do the other problem we need to talk about.